Hi, welcome to Preamp Repair, and today we're going to go through this Ampeg SVT 3 Pro. This came in for service, and this one had a catastrophic failure in the output section and had been to someone else for a repair attempt that was unsuccessful. So I got it after someone else had their hands in it, and I'll talk about the consequences of that as we go through it. But basically, this amp has been repaired, but I think there's still some value in talking about the thought process for repair, the approach to the repair, at least how I did it, and talk about how to achieve success in a relatively safe, low-risk way. So the first thing that I did was, as always, a visual inspection. So a lot of times, I would say probably 70 to 80% of the time, I can visually see something that's an indicator of a problem area. So on this particular amp, right in this location, you can see pretty heavy circuit board burn. There was a 300 ohm resistor there that's part of the bias circuit that had burned up and damaged the board, and actually damaged some traces on the bottom side. And then this particular MOSFET back here, I could see one leg of this had arced and blown off. And then I could see a little circuit board burn here, and one leg of this MPSA6 had burned or blown off. So I could tell there was some pretty significant damage. And so without really assuming anything or going any further, the first thing that I did was move towards removing this circuit board so that I could do some more thorough testing. So on this side of it, everything is removable with spades. There is a service manual and a schematic available for this, but I always recommend taking high resolution pictures in case you don't have the luxury of that. This particular schematic shows you the color of the wires and the location that each one goes, and it's well labeled, and the service manual in that regard is outstanding. So very low risk at taking this out if you have that resource. So basically, to get this out, you have to take the nut off the toroidal transformer here so you can free it up, get it out of the way, and then the power switch comes in. Excuse me. This ground connection comes on the corner here, and then you can free this side of the board up. Then there's only a couple of screws, and then of course you have your jack connections across the back. And then in this area here, this screw right here, and excuse my head popping in, and this one right here, if you take those out, basically this whole thing, including this heatsink and fan, come out with the board, and it's not difficult. So I undo this connector and take this daughter board out completely, undo this connector here, and undo the fan connection, and then this whole board assembly comes out, and you're free to work in it. So the first thing I did was remove all of the output transistors and all of the source resistors. These were cracked and just worn. You could tell that they had experienced a lot of wear. So all of the source resistors were removed and all of the power transistors were removed. Then I tested, and 7 of the 8 were bad. And most of the source resistors actually tested good, but I replaced them just for best practice. So I did replace the source resistors, but I did not replace the output transistors. What I wanted to do is put the board back in without output transistors so that I could do some testing on the power rail. But only after I had done some more thorough testing based on the visual observations. So obviously this MPSA 06 was bad. Then this transistor, this one here, Q2, tested good. These two transistors tested good. Both of these were shorted. So I ended up replacing the MPSA 06, and then one of these is an NPN and the other one is a PNP. Replace both of those. And then I also noticed that 3 of the 4 gate resistors for this side were open. No conductivity. So I replaced all 4 of these gate resistors on this side. And then I also ended up replacing the 13-volt Zener diodes and the 1N3070 diodes. There's 4 of each of those. 2 of them are located on this side of the board. I had to remove these 2 capacitors to gain access down there to do that work. So the 2 Zeners here I had to replace. The 2 13-volt Zeners here I replaced. These 4 gate resistors I replaced. These 4 diodes I replaced. And then to begin with, these 3 transistors here. This tip transistor here is for the B+ voltage for the power tubes, and I had good high voltage there, come to find out. So with that tested and the new components installed, but without without the output transistors, I put the board back in. Still no connection to the preamp or the daughter board. What I was looking for were the power rails, high voltage, low voltage, and to see that I got a response with the bias circuit. So as always, best practice, I put my variac into my current limiter. So this was current limited, and I started with my variac at 0, and I crawled it up to about 20 volts AC. And this 100K resistor, let's see, this guy right here, R62. This resistor, and there's one in the back corner, were my test points for my high voltage, and that seemed to be coming up proportionally. What was really odd that threw me off was the lower voltage on the top and bottom of the bias circuit. The top side looked about right. In my case, with the variac at about 20, I was getting 4 to 5 volts on the top side, but the negative side was also positive. Very low positive, but not the counter negative like it should have been, which really threw me off because my high voltage was, and I'm looking at the circuit, and come to find out, this Q6 had been replaced with an MPS 06. So even testing the transistor in circuit, knowing it was good, at the time I wasn't cognizant that it was the wrong component. So this is an NPN, and it's supposed to be a PNP NPSA 56. So this is something, you know, working after someone else, that one of those follies. So I replaced this with an MPSA 56, restarted that process again, and voila. As it was coming up, I had my appropriate plus and minus voltage in the bias area of the circuit, and I was able to create the load and see some response there. So that was a great step. I could tell I had my voltage rails. So then I brought it up to about 60 volts. Everything still looked good, no sizzling, popping. And then I brought it all the way up to 115 volts and checked all my voltages. Everything looked good. So that was promising. So at that point, that's when I installed the new MOSFETs. So this side has a quad of IRFP 240s, and this side here has a quad of IRFP 9240s. Whenever you replace these, you can't replace them just 1 or 2 at a time willy-nilly. You must get a matched set. Very important. If you don't get a matched set, then 1 or more of these will run hot and eventually burn up, and you'll be right back where you were. So I ordered an octet matched set for this amp, And I also put new thermal pads behind each one of the MOSFETs when I installed it. This is just FYI. When you heat this up, put it through a heat cycle with the thermal pads. Let it once it's been through a heat cycle, revisit each of your tightening bolts here. Give it another good 2-finger tight after a heat cycle. Just best practice. So then once the MOSFETs were reinstalled, again without power tubes, without any connection to the front end preamp, still current limited and still bringing it up from 0 on the variac, then what I wanted to see was my bias voltage come up slowly. So on this amp, ultimately what you're looking for is 23 to 25 milliamps across these source resistors here on either side. But if you use the left side here, you'd put your positive lead on this side and your negative lead on this side. Set your multimeter to millivolts. And so I brought it up to about 20 volts AC, and I could start to see this bias voltage come up to just a couple of millivolts, which was wonderful. And then I creeped it up a little bit more, and I could see the bias voltage come up slowly. So just to be aware, if you literally breathe on this, it will jump. So you have to be very careful and very deliberate and very slow. You just creep this to set your bias, which on this particular amp, the technique that I use which is really helpful to dial it in, is to put it on a variac and bring it up slowly. That way you don't get caught off guard and over dissipate the MOSFET. So I brought it up and was cognizant to dial this in, and the higher the voltage got, the more I tried to keep this tuned within that 23 to 25 when it reached the peak. So once this reached the peak, I was at about 21 millivolts. And then again, once it's good and hot, you just kind of play with it. Again, you just kind of breathe on that and it adjusts. But I was able to get a perfect bias on it at about 24.6 millivolts, and it held steady there, so I left it. So at that point, I retested the power supply for the tubes, and everything was looking good. So at that point, I shut the amp down, reinstalled the preamp. This particular location had a 12AX7 installed. This is supposed to be a 12AU7. And then the others, after testing the tubes, 2 of them were pretty weak. I replaced 2 of the preamp tubes on this one and then put a excuse me, 12AU7 there and a new 12AX7 there. So at that point, with everything connected, once again, I brought it up slowly on the variac and current limiter. Once I brought it up to voltage, I didn't see any issues, so then I turned the current limiter off, and I was at operating voltage. I had lights here. At that point, I attached a speaker and put a test signal in it. In this case, I put an 8 ohm load on the back of it, pretty conservative, so I could watch the signal on the scope. And I had beautiful sine wave, clean output, and everything was as it should be on both sides. I had good output. So in this case, a little bit tedious, a little bit of a rabbit hole due to a previous repair attempt, but I wanted to share my thought process and some of the logic in going through the repair of this particular amp. So these are really built like tanks. I don't see this kind of catastrophic very often in these amps. I've worked on a dozen or so of these over the last few years. And on this amp, one of the things it is notorious for is drifting on bias, over years. So this amp, while it would normally be performing pretty well, will sound really ratty and distorted, even at all other things being equal and the same, if the bias is too low. So usually you'll find, just a couple millivolts on these, or maybe even 0, and it'll just sound horrible. And so that's where you would go through the bias procedure, assuming the amp is operating normally. Highly recommend the Variac and your leads across the source resistor so that you can kind of dial this in as you're ramping up the voltage, because it is so sensitive. And once you get this between 23 and 25 millivolts, that'll clear right up and be just a beautiful clean sine wave. And then it's always a good idea, you know, without a good tube tester, you're really running blind. So I have a BK747 tube tester that I've put a completely new circuit board in, brand new components, and I calibrate it about once a quarter. It's just one of my main go-to best pieces of test equipment in the world I live in. You can't look at this piece of glass and tell me what the transconductance is. So, you know, without good test instruments, you're flying blind. So you can see I've written, well, you probably can't see, but I've written with blue Sharpie on the outside of these where they tested out. So in this case, I had one bad tube installed, the incorrect tube, I should say. This was a 12AX7. So out of all of these were 12AX7. So out of the 5, 2 tested bad. So I put the 3 best ones here, which were very good, and I put a new 12AX7 here in the gain stage that's adjustable by the knob on the front, and then I put a 12AU7 new one in here. But again, a good tube tester so you can test each half of these triodes, what their transconductance is, because these can really lead you down the wrong path if you don't understand scientifically where they are at. So knowing up front that these tubes were tested was key to the confidence after a significant catastrophic failure in the output section to achieving success here in a methodical way. So that's that. This one, obviously, I went through the whole process, and this amp is repaired and restored and in perfect operating condition again. The next one I get, I'll go through the process with you so you can kind of see what I experience as I go through it. I've got a Crown CDI 1000 amp in the shop right now that I'll do a little, I've gone partly through it, but I'll give an instructional video on that. And I'm going to do some mods to it that are very functional that I think will be valuable to the audience. But anyways, SVT3 Pro, fantastic amp, and just really built like a tank. Not a lot of problems on these that I experienced, mostly bias and tubes. This particular customer had brought a pair of these in, and the other one just needed to be retubed and bias, and it was fine. So again, very high quality amps, good construction, good service life, and if you have one with a catastrophic failure, hopefully this thought process was helpful. Just to finalize what I actually had to replace in this amp. These 2 caps were removed to get access to replace the 13-volt Zeners. I replaced both of those on this side. On this side, I replaced that pair of 13-volt Zeners. I replaced all 4 of the 1N3070 diodes over here. I replaced, I think this is a 3440 and this is a 5414. I replaced the high voltage transistors, replaced this MPSA 06, replaced this MPSA 56. For good measure, I put another 330 ohm, a brand new one here in this location, and then I replaced all 4 of these gate resistors with, I think these are the 4.7 ohms. And I put a little bit higher wattage ones in there so they would run cooler, just what I replaced it with. So anyways, that was this, and then I left this one in again because it was part of the previous repair and it involved damaged circuit board traces on the bottom, but it was actually repaired nicely, so I just decided to leave it in place. No harm, no foul there. So that is the final on this one. in my approach, and I look forward to sharing my next video with you. Take care.